Hi, in this lesson, we'll take a deep dive into constructors. In past lessons, we learned that objects have both a state and a behavior. The state of an object refers to its attributes and the value of those attributes. In this example, the rectangle class has the attributes of height and width. This particular rectangle, rectangle 1, has a height of 8 and a width of 20. An object's attributes are defined by the class's instance variables. All and any instance variables should help define the attributes that make up a class object. We can set the initial state of an object's attributes through a constructor. Using the formal parameters of the constructor, we can take in actual parameters that are copied into the constructor as local variables and initialize the values of a class's instance variables. It's important to note that we can also initialize the value of instance variables without a constructor. If a class does not have a constructor written, Java allows us to use a no-argument constructor to create an object for that class. If the instance variables have not already been initialized, Java will initialize them with a default value. In this example, the rectangle.java class does not have a constructor. When we create a new rectangle object in myprogram.java, we are able to use a no-argument constructor, even though the class does not have one written. When we print out the value of width and height after constructing a new rectangle object, we can see that the value of width and height have been initialized to 0 by Java. In this lesson, we will take a deeper look into creating constructors that take objects as a formal parameter. In order to do that, we will be creating a couple of example classes. For this lesson, we're going to build a superhero class. Each of our superheroes will have a name and a power. These are the attributes that we expect each of our superheroes to have, and thus will be our instance variables. We refer to this relationship between an object and its instance variables as a has-a relationship, as a superhero object has a name and a power, attribute, or instance variable. Each power also has its own set of attributes. A power has a name and a strength associated with it. Because power has multiple attributes, we can make a power class as well that allows us to store both the name and strength attributes in a power object. Here is another way of looking at the superhero class that we are creating. We can see that superhero has two attributes, and one of those attributes has attributes of its own. When creating classes, writing out the attributes this way can be a helpful way of organizing what data types each attribute should be and whether they are necessary. Let's start by writing the power class. Can you figure out the implementation for this class yourself? Pause the video before moving on. Here is one implementation of the power class. We have two instance variables, name and strength, and our constructor has the parameters the name and the strength to allow users to input information about the specific power they would like to build. Let's also add some accessor or getter methods to this class so that we can get information about the name and strength of each power. This is going to be useful for us in the future. Now that we have a working power class, let's take a stab at building the superhero class. Before moving on, can you figure out the implementation? Here is a working implementation of the superhero class. Notice that we have two instance variables, name and power. The constructor also has two parameters that allow the user to input the hero name and the power. It's important to note that one of the parameters and instance variables in this program are objects. Just as with any other data type, objects can be used as data in other objects and can be initialized into variables. Notice that we use the data type of the object before the variable name. If you figured out this implementation on your own, congrats! There is, however, a pretty substantial problem with our current implementation that revolves around our initialization of the superpower object. Let's explore what's wrong with this. Let's say we want to create a new superhero. We create a new power called speed that has the name super speed and the strength of 10. We then want to assign that power to two superheroes that have super speed, Flash and Shazam. We use the same speed power because we want both of them to get the same power to start off with. Now, both the superpower power object in the Flash and Shazam have the same attributes. However, if we want to change the value of strength for the Flash, something interesting happens. The value of strength for Shazam also changes. Why is that? This is because both the Flash's superpower and Shazam's superpower reference the same speed object. Remember that when a variable is assigned the value of an object, it points to the existing object and does not create a new one. Because of this, whenever one of our superheroes changes the value of any speed attribute, it will affect the other superhero. When a variable is referencing an existing object, it is referred to as an alias of the original. In this case, both superpowers are aliases of the initial speed object. So how can we fix this? Instead of having the superpower power object reference the power object input into the parameter, we can assign the values of the power object to the superpower object. In the constructor, we can initialize the superpower object by creating a new object using the values of the power attribute. Remember the accessor methods we created? We can use those to get the value of the power attributes and assign those values to the superpower power in the constructor. This means that each individual superhero will have a power object that is exclusive to that superhero. Any changes that are made to the superpower object will only affect the individual superpower for each superhero. When creating constructors with objects as parameters, it's important to keep this in mind so that we are only changing the objects that we intend to. Now, with our new initialization, when we change the strength attribute in the Flash, the Shazam superpower strength will not change. Here's a live demo of the superhero class. In the initial run of the program, we have superpower equals power. Notice that when run code is hit, the value of strength also changes for Shazam. When we initialization of superpower to initialize a new power object, when we run the program again, we get the correct value for Shazam. Now that you've learned more about constructors, let's get some practice using them in the editor.